all of you. Welcome back to the study of acids, bases and salts, where the first two parts were dealt with acids as well as bases. If you remember, the first part was a complete thorough study of acids, whereas the second part was a comparative study with respect to acid for the bases. And towards the fag end, we came across one reaction, neutralization reaction, which was acid plus base gave rise to salt and water. And that compound salt is what we are going to study in this part. So before we go into the discussion of salts, let us see the answers for the assignment that was given in the last class. All alkalis are bases, but all bases are not alkalis. How? This is dependent on the definition of the compounds, where we saw that bases are generally those compounds which will have this OH group and all, but alkalis, they are those bases which are soluble in water. So that subtle variation in the definition is what separates in these two systems, where inwards the answer has been provided to you here. So important aspect, base is the one which is giving OH ions, alkalis are those which are only soluble bases. The second answer we have, how is the concentration of hydroxide ion affected when excess base is dissolved in the solution of sodium hydroxide? So please remember that in the first place you already have, when you consider sodium hydroxide solution, you already have NaOH. Now in this NaOH system which is there, when you dissociate it, if I supposedly believe that this is a strong base, already I am getting a production of OH minus. Now what is the question? What is the concentration of hydroxide ion, or basically how it is affected when some more base is added? So when excess of base is added, naturally it means that more number of OH minus ions are generated, which indicates that it will be basic in nature. So how is it explained? Since NaOH has OH ions in it, already there is a presence of OH ions. On further adding a base to NaOH solution, it will again start producing OH minus ion. So naturally the concentration will definitely be increasing because of excess OH minus ion which are present. So this is the second answer that we have. Then the third question, do basic solutions have H plus ions? If yes, then why are these basic? Generally we have studied that the basic compounds are those which have OH minus ions. But what happens here is, when you take an example of say ammonia, NH3. Now actually this ammonia, not ammonium hydroxide, ammonia can produce H plus ions. But when do we consider it as basic is because OH minus productions will be large, or to say the basic nature of these compounds will be large. So no doubt some amount of H plus ions may be given by these compounds, but excessive basic nature is being shown by these compounds. So this is about the study of various bases that we have studied, and now let us get into today's topic, where salt. What's a salt? It is basically a product formed when an acid reacts with a base. So you can see here that basically when there is an acid, as an example HCl and NaOH, a simple reaction that has been repeated to you many a times is shown here, where NaCl is the salt which has been generated, H2O we call them as byproduct. So what is happening here is, in HCl it is H plus and Cl minus when you dissociate it. In NaOH it is Na plus and OH minus. This is the dissociation. I am sure we have understood this part very well till now. Now what we see here is that from acid, the negative part, from base the positive part combines to form salts. Let me repeat it once again. In acid the H plus goes out to form water, whereas the negative part goes to form the salt. Whereas in the base OH minus ion go to form water, Na plus ions will combine with Cl. So this is how the overall formation of salt happens whenever we undertake a reaction between acid and a base. This is one method of preparation. Now this doesn't mean that salt can be prepared only by this method. There are various other methods also which we will be seeing now, where base, again if you see acid base combination, Base remains the same, but non-metallic oxides are utilized. This we have studied in the last class, where non-metallic oxides are nothing but carbon dioxide, carbon monoxide, nitrogen oxides. What are non-metallic oxides? These are those oxides which do not have any metal. See, sodium is a metal, potassium is a metal, but carbon is not a metal. So these non-metallic oxides can be used, and base, naturally OH compound which is there here, can react with the non-metallic oxide to obtain salt. This is one such example that is possible. There is another example where acids are reacting with metallic oxides. So what are metallic oxides? A combination of a metal and oxygen which is present. So these type of compounds can also form salt in these cases. So what I have done here is offered you one example as such. You can go for various other examples also. For example, if I have to just extrapolate the discussion regarding this, the base that was used here was CaOH twice. Let me use NaOH, sodium hydroxide. Now when I use sodium hydroxide, let me take the non-metallic oxide, carbon dioxide, because it's a stable oxide that is present. So what are the products here now? The product will be Na2CO3. This will be one product, because kindly remember that calcium actually has +2 charge, whereas sodium has +1 charge. So that is why that product has been formed. And what is the byproduct that we see here is nothing but water. Now the question is it balanced? Well, you can see one sodium here, two sodium atoms there, so definitely you have to go with 2 NaOH. What else we can see here? In total, we now have 4 oxygens, 2 oxygens here, 2 plus 2, 4. That side also, on the right side, you have 3 plus 1. Hydrogens, you have 2 hydrogens available here. These are the 2 hydrogens, and 2 hydrogens are available in water. So this is how you can write the balanced chemical reaction for these parts. Moving further, some other methods of again preparing salt. We have acidic oxide and basic oxide. Acidic oxide, it's a non-metallic oxide, which you can say here. Basic, because it's a metallic oxide. So metallic oxides are basic, non-metallic oxides are acidic. So combination of these two can easily give us various salts which have been present. And then finally metal plus acid. This, if you remember, was the very first set of reaction that we had studied in acids part, where metals can react with acids to form corresponding salt, and hydrogen gas can be liberated in these cases. So these are the various methods. So if I have to just revise here, the first up, it is acid plus base gives salt and water. Then we have base and non-metallic oxide, acid and metallic oxide. Everybody is giving you salt. Byproduct water is coming out. So here there is no byproduct as such. So what is a byproduct? You don't need it, but then it comes about. If it doesn't come, fine. So here there is no byproduct as such, whereas here the byproduct that comes here is hydrogen. So this is how various salts can be prepared, and the moment we know these salts, the question now comes is, where do we use this? Well, one salt that you can very easily understand is the table salt which is there, which is NaCl. But that is not only the salt that is present. In our day-to-day language, we say that salt essentially means NaCl. But no. When you talk in terms of chemistry, those compounds which have a combination of a positive part and a negative part, by which I mean that a positive basic ion and a negative acidic ion, all of them come under salts. So CaCO3, calcium carbonate, that is also a salt which is present. So let us see some of the important salts that are present here in these cases. Let us see those parts now. Some important salts, certain pictorial representation is also given for you. Caustic soda, this is one of the salt that has been used in mainly reactive purposes. Bleaching powder, this is mainly for cleaning. You have this cleaning purposes available here. Baking soda, think over this. Where do you use this baking soda? Again, this needs your mind to be there in kitchen, because this is used in the kitchen by your mother or maybe by yourself if you are interested. Washing soda, used in many washing purposes. Plaster of Paris, this is the diagram that we have. What's this? Seems like somebody is injured and he is being plastered. This you must have come across many a times, but what are these compounds chemically? That let us study in detail for each of these 5 compounds which are there. So let's start then. Let's start with the first one, caustic soda. This is nothing but sodium hydroxide. So sodium indicates NaOH. This is something that we have been using for a long time for our various reactions. The common name that we call it is caustic soda. Now in this we have 2 segments. One is common naming, IUPAC naming. IUPAC naming is something that is a systematic procedure that is followed, whereas common naming is not like that. It is dependent on the names that are given where it is used in large quantity. So this caustic soda, you can prepare it by a method called as chlor-alkali process, where alkali, we know very well, they are soluble bases. This was something that we have studied in the last class. So from that we can obtain sodium, and chlor indicates chlorine. So chlorine gas comes out, and that chlorine gas, when it combines with sodium, we can undertake these reactions. But generally the process that we use is electrolysis. Now what is electrolysis? Electricity. Lysis means breaking. The word lysis indicates breaking. So using this electrolytic process, this NaCl solution which is there, we call this as brine solution, where when you undertake electrolysis, what does H2O here mean? That it is the solvent. So you will get NaOH. Chlorine gas and hydrogen gas are also obtained, but our required product is NaOH, which is present here. So this is about the caustic soda that we look for. Then what are the uses of this caustic soda? The first thing is in refining of petroleum, because petroleum you actually get it by mining the fossil fuels as such. You have various parts in it, say benzene, petrol, diesel, all this. So in the refining process we use this compound NaOH as an electrolyte in alkaline batteries. So what is this electrolyte? You must have studied that. Suppose if you have a beaker and then you use 2 electrodes for electric current. Now the solution that is present here, with the solution that we use, we call this as electrolyte, and generally we use this as NaOH. Now this is the basic principle that happens in all your batteries. So they use an electrolyte, and that is how your batteries run in place. It's also used in the manufacture of soap, paper, textiles and medicine. Certain pictorial representations that are shown here, like the battery that was being used in textiles and all. And this is more the refining process that we undertake, where with support of NaOH, the refining machinery which is there is able to segregate various products of petroleum. So this is about caustic soda that we have, and the next one is bleaching powder. That's a common name. Chemical name is calcium oxychloride. So calcium means Ca, oxy means oxygen, chloride. Now for balancing of this part, it is actually written as CaOCl2. So that's the formula for calcium oxychloride. The formula is a little tricky because many bondings and all take place. That is not there for you at this level. All you can know is the formula that is present for this compound and how it is prepared. That is also important. Calcium hydroxide, CaOH twice, is been treated with chlorine gas which is present here, which will give you this bleaching powder. Now where do you analyze this bleaching powder is, suppose if you have used this bleaching powder, especially say for cleaning of your bathrooms and all, the moment you put this bleaching powder, you get a very irritating smell. Now what's that irritating smell is, this bleaching powder, when it is used for cleaning purposes, it gives us chlorine gas, and that chlorine gas is irritable in nature. So this is how we use these bleaching powder for our day-to-day uses. We have some uses here for bleaching cotton and linen. So basically in the textile industry, what is textile? Clothes and all. So there, to make it in a pure form where all the impurities you can remove, this process of bleaching has been employed. You can see there for wood pulp in paper factories, for bleaching washed clothes. Generally washed clothes will have a lot of impurities, and if you use this bleaching part, it can remove many such impurities. That is why it has an important use in laundry. So in the laundry, because it has very good cleaning properties, this has been used. Used as an oxidizing agent and disinfecting drinking water. As I told you, especially in drinking water, they add this chlorine. If you undergo or if you can find a process of purification of water, this bleaching powder is added so that the chlorine which is present will kill all the harmful microbes which have been present in the water. So this is about uses of bleaching powder, and then we have baking soda. Baking soda is used mainly in the food industry. You can see that when you eat a cake, it's a pretty much fluffy in nature. Say even when you eat bread, that is also a little fluffy in nature. That fluffiness comes because this compound is added. So what is this baking powder, in this case as baking soda, is sodium bicarbonate system, where sodium, H and CO3. Bi indicates the hydrogen which is present. So NaHCO3 compound is been used, and that is why you see here that this soda is commonly used in kitchen for making tasty crispy pakoras. Mainly what we understand by this baking soda here is that it is able to offer that crispy nature or fluffy nature for the food items. This is the methodology of preparation, where you see that sodium chloride, water and carbon dioxide very readily available, and ammonia gas has been used. With combination of all this, you will get ammonium chloride and baking soda, which is here. Ammonium chloride is the byproduct that you may not require in this reaction, because our main product is the baking soda that is there. Now what are the uses of this? The very first use is utilizing it as baking powder. So what is this baking powder is? Basically it is a combination of baking soda and tartaric acid. You can see there pictorially the parts that have been present. How do we make this baking powder, where double the amount of tartaric acid is taken and baking powder is formed. So why is this baking powder required is because commercially it is used in the powdered form, so that the acid also which has been present helps in formation of the crispy nature for the foods that are present. So when you undertake this baking powder, because baking powder or this baking soda, if you see, it is NaHCO3. So very easily it gives away carbon dioxide gas from this case, and because very easily it can give carbon dioxide gas, that gas which releases when baking powder is used for food materials gives the fluffy nature for items like cake. So sodium hydrogen carbonate, it is also an ingredient in antacids. What is an antacid? We have already studied something anti-acid, which acts against the action of acids. This is generally neutral compound as such, alkaline of sorts, where you can also use it in the fire extinguishers, because since it generates carbon dioxide, the baking soda generates carbon dioxide, and we know very well that oxygen is the supporter of combustion, carbon dioxide does not support combustion. So therefore it can be used in fire extinguishers, because if somewhere fire has been lit, you can extinguish that fire. So this is about baking soda which is present. The next one is washing soda. The formula you can see here, it is sodium carbonate, Na2CO3. That sodium carbonate you have come across many times, but what is this 10H2 is? We call this as water of crystallization. So crystals of water which are accommodated with this sodium carbonate compound, we call this as washing soda. So what happens here is, sodium carbonate compound will be there as such, and the water will not mix thoroughly inside, it will just be present outside the system. And that is why you can see that how do you prepare that is utilizing the sodium carbonate salts which are readily available, mix it with good amount of water. So with excess of water when you mix it, it will lead to the formation of washing soda. And the name itself gives you an idea of what are its uses. In this case, very useful chemicals for industrial process, because lot of process requires removal of byproducts, cleansing and all. So this washing soda can be a very good utility compound for these cases. We have washing soda uses in glass, soap and paper industries, as well as used in preparation of sodium compounds and all, say like borax. Borax is a combination of sodium, boron and oxygen. So that in those compositions you can use. It is used for removing permanent hardness of water. Now what is this permanent hardness? Generally there are areas where the water is pretty hard. Especially when you start washing your clothes, you will realize that in some areas more water is required, because there are a lot of ions that have been present and it will be difficult to wash the impurities of the clothes. So what you can do is, if you use washing soda, it will decrease the hardness of water and therefore it will be easy for our usages. So this is how various uses of washing soda can be found. And then we have one last salt that we have here, which is plaster of Paris. Now the chemical formula is calcium sulfate Hemi. Hemi indicates half a thing. So what it indicates is calcium sulfate CaSO4 is combined with just half molecule of water. If you remember, in washing soda, we had sodium carbonate solution with 10 molecules of water. Whereas now we have this calcium sulfate with half a molecule. The other way that you can write it is you can write it like this also, 2 CaSO4 H2O, which indicates that for 2 molecules of CaSO4 there is 1 molecule of H2O which is present. So now, but this is an important thing, since only half a molecule of water is there. If you heated this compound to say around 100 degrees centigrade, its original compound which is there, which is nothing but gypsum. So how do you obtain this plaster of Paris? We have this white color compound called as gypsum, which is nothing but CaSO4 2H2O. So when you supply heat, and how much is the heat supplied? It is 373 Kelvin indicates, this you have studied in 9th standard. So 273 Kelvin indicates 0 degree and 373 Kelvin indicates 100 degree, which happens to be the boiling point of water. So when you heat it at around 100 degrees centigrade, this is the gypsum that is formed, and this amount of water, that is 1.5 molecules of water, gets evaporated. That will not be of any much use for us. So this is how preparation of plaster of Paris is done, and the best use, well, this is something that you are already rightly aware of, where especially when you are hurt and if there is a bone displacement in your body, then plaster of Paris is put so that you don't move your arm or any fractured place as such, so that the bone gets sufficient time to adjust itself to the original position. So there you can see that that is one big important use that we see. Along with this, the other uses plaster of Paris is used for casting various idols or anything. Many of our earlier Ganesh Chaturthis actually have run with this plaster of Paris. But nowadays they are telling us not to utilize this, because the problem is decomposition is a problem. So no doubt with mud when you make idols it is best, but then people go for this because it is pretty much cheaper, but not biologically a very good compound to be used. So this is how we can use the plaster of Paris. Now we have to be careful that this plaster of Paris which is there, if you put water on this plaster of Paris, I think some of your houses will have a roofing of plaster of Paris in where nice designs are made. You put water on that, then all its properties gets dissolved. Basically I mean that the plaster of Paris roofing that you have done will not be stabilized further, because when you put sufficient amount of water, that is 1.5 molecules of water, it will become gypsum, which again is a hard substance. That is why whenever you wear a plaster, you are advised not to put water on that, because if you put water on that, over a period of time it will become very hard. It is going to be a painful experience for you when they remove the plaster back. So therefore, that is because it absorbs the molecules and becomes like the starting compound, which is gypsum. So these are certain uses of plaster of Paris, and this actually completes large number of salts that we have studied. Just as a revision, let's go through some of the salts which is there here. We started with caustic soda, NaOH, preparation method which is available here, some uses, petroleum refining as an electrolyte in batteries and various other textile materials and all. We then went to bleaching powder, which was mainly dealing with cleaning reagents as such. We have a preparation for that. Main usage, we know it to be in laundry. This is an important part which is there, or say paper factories and all, where you bleach the cotton clothes or papers, those kind of compounds. Then baking soda, mainly used for food industry, so that the carbon dioxide that this compound gives away helps us to form crispy nature food or say fluffy nature food. So this is about the baking soda. Some of the uses that we have a small diagram there of the bread, brown bread that we can use, or the cake. Washing soda, this is mainly used for washing purposes. We have this chemical formula which in the 10H2O indicates that they are combined together. These are some of the uses. The final one, plaster of Paris, mainly used for plastering the hand or any fractured part so that it retains its stability. So having seen all these parts, let us see the assignment here. Chemical name and formula for the 4 compounds. You have just discussed this extensively. So just for your revision, you can just write the compounds. Which compounds are used for the following purposes? Softening hard water, please. You have to refer back now for the uses of the salts that we have studied. So which compound we use for softening hard water? Textile industry. Soda acid for extinguishers supporting fractured bones. So this is more about understanding the uses of salts. And then the last question, plaster of Paris should be stored in a moisture proof container. Why? This deals directly with the property of plaster of Paris itself. So hope you have got a good idea about salts which were basically prepared by acid base type of reactions and various uses that we do come across in our day-to-day life. See you again for the one last part that we have in this particular chapter. Thank you. Sai Ram.